right. Hello, everybody. I believe I'm recording. If I'm not, then you won't hear this at all. I probably say that joke at the beginning of every video. Put in the comments if that's the joke I make every single time there's a review video. All right, I'm stalling. Let's put this pen on, and if you stick around to the very end, because it's going to be a long one, like we all know, if you stick around to the very end, I'll tell you how my parents tricked me and my brother into believing in Santa Claus for 3 years longer than we probably should have, and the exact trick they pulled. All right, I'm trying to arrange my video, I think. Okay, so here we go. We've got exponent rules to start with. We've got all the same base, so 5. When we added all these up together, it created -2. Remember what we learned about negative exponents. For some reason, we don't like them. So think about what is 5 to the power of 2. 5 to the power of 2 is 25. So 5 to the power of -2 is the reciprocal of that, 1 over 25. So that's going to come in later where we flip the script on those negative exponents. Comes up in this very next problem, actually. Okay, so as you go through this next one, letter B, 25 divided by 5. Stick with numbers first. I would say 25 divided by 5 is 5. X to the 14th divided by x to the 7th, just like you add exponents when multiplying, you subtract them when dividing. So that would give us x to the 7th. So now I have 5x to the 7th. And then this is where it gets a little tricky. Y to the 20th divided by y to the 22nd would be y to the -2. Remember what we just said about negative exponents. Y to the -2 is like saying 1 over y to the second. Okay, so think about we have 5, we have x to the 7th, and now we have a y to the second that wants to be in the denominator. We've got 5 and x to the 7th in the numerator. If we had the 1, multiplying that all by 1 would just leave it as it is. We'd leave y to the second in the denominator. 32 to the power of 3/5. It's a tough one to think of, maybe. Well, maybe not that tough, but let's think about it like this. So we've got the fifth root of 32, and that number is going to be taken to the power of 3. The fifth root of 32 happens to be 2. Take that number to the power of 3, and you get 8. You're still wondering, well, how can I figure out the fifth root of 32? Well, you could just do 32 to the power of 1/5 in your calculator, right? And that would give you 2. And then you have 3 of these fifths, right? So you essentially take that number 2. And again, however you want to slice it, you can say, hey, 2 to the power of 3 is 8. So there's a couple different ways to arrive at that answer. An important thing to remember, though, I like to use 25 as an example. 25, the square root of 25 is 5. If you did in your calculator 25 to the power of 1/2, you also would get 5. That's because you're saying the square root, the 2, and 25 to the power of 1. So that's the example I like to use. It's a little more obvious because we don't always think of fifth roots, but usually square roots can make sense. All right, this is some old school solving. You got to think of all of these square root symbols as parentheses. This 2 is being multiplied by everything. So to get rid of it, I am going to divide both sides by 2. So now I have root x minus 3 equals 7. I want to get rid of that root. The opposite of it is squaring. So now I have 49 equals, got rid of that root. Now I just have x minus 3. Add 3 to both sides. Might be going fast for people, but come on, you want to hear this Santa story. Also, you can pause, rewind, go slow, whatever you need to do. Usually with these square root ones, just like to double check your work, especially with negative square roots hanging around, right? 52 minus 3 is 49. Square root of 49 is 7. Is 2 times 7 14? Certainly is. So I double checked that. Let's get a green here. Let's take 5 away from both sides, right? Because I'm still thinking of this like it's a parentheses. That means it's the last thing I undo. Take 5 away, and now you have negative 2 equals square root of 2x plus 3. Now that should be a red flag right there. Are you ever going to take a square root and get a negative? And a bunch of people saying, oh, we learned about imaginaries right now. We can take square roots of negatives now to get imaginary answers, but we'll never get the answer that is a negative to a square root. Kind of funky that way. Um, okay, so if it didn't tip you off that this is a no solution already, fine, go through the process. That's okay. Okay, square both sides. And you get 4. Yes, you have to be smarter than your calculator here. 2x plus 3 equals 4, not negative 4. Take 3 away from each side. 2x equals 1. Divide both sides by 2. X equals 1/2, or does it? What's 1/2 times 2? Look, I'm putting that in here. 2 times 1/2 is 1. 1 plus 3 is 4. Square root of 4. 2. Is 2 plus 5 3? No, it's not. So we actually have no solution, which we should have been clued off by earlier. And we were. We just, we like to double check things, which is good. Good to double check. All right. Take 3 away from both sides here. Now we have cube root of 2x equals negative 2. And you're like, oh, no solution. Cubes can be negatives because negative times negative is a positive, but negative times negative, positive, times a negative is negative. So you can have negative cube roots. So that's okay. So I'm going to cube both sides to get rid of that cube root. And now I have 2x equals negative 8. Going to divide both sides by 2. X equals negative 4. Onward. All right. This is just a fancy way of combining like terms. We've got these eyes. We still can't see. All right, 4 plus negative 3. So I'm taking negative 3. I'm adding it with 4. That gives me 4 minus 3, which is 1. I'm taking the negative 6i. Again, I'm adding it, so that's why it's just staying as it is, negative 6i. 5 minus 6, that's negative 1 or negative I. Little different here because I'm distributing this negative, so I am ending up subtracting the 3, but I'm going to, after distributing this negative, be negative, negative, adding the I. Negative 3, negative 2 and negative 3 combine to make negative 5, positive 7, and positive 1i combine to make 8i. Again, these are just subtraction and addition problems. We'll be multiplying later, getting a little tougher. So negative, negative again makes positive 15. Negative, negative. Ooh, this one's tricky because when we multiply, oh, it's not that tricky. So I was getting ahead of my skis there. All right, negative 2i. 20 and 15 make 35. Negative 3i. I was getting ahead of myself because I was thinking of multiplying, which we're about to do. all the solutions to the equation x squared equals negative 16. Did I guess there's a couple on there. You'll have to check the regular key. No, I'm not going to be able to say to skip all of those. I got to do those. All right. Okay, I'll just clear this work and rewrite the problems. Okay, because you have D, E, and F. I don't want to skip all those multiplication problems. Let's look at D. 3i. Might run out of time here in my recording because of it, but hey, it's okay. We'll get there. I'll do a second one if I need to. 3i times 2, I would say 6i. 3i times 10i, you end up with 30i squared. I squared, remember, is like saying -1. So 6i plus -30, you end up with -30 plus 6i. Try to put the real numbers first. If you wrote 6i minus 30, I don't think it would be the end of the world, but okay. The next one, -2 minus 3i. All right, I need to worry less about room and just do this stuff right. And I will make more room when I need to. See, I'm talking myself through it. Let's get a different color though, so this stuff doesn't blend. All right, good old-fashioned box method. -2 minus 3i. And 3 plus 9i. Lost my mojo there for a minute. Let's get it back. 3 times -2, -6. 3 times -3i, -9i. 9i, -2, you get -18i. And 3 times 9 is 27. It's a negative. Therefore, it should be -27. I times I is I squared. I kind of skated over this a little too quick, maybe. Remember, the square root of -1 is I, which means that I squared is the square root of -1 times the square root of -1. So I squared effectively is -1. All right, I'll say that again. I squared is -1. Therefore, -27i squared, that's like saying -27 times -1, which makes it positive 27. 27 and -6 together make positive 21. -9 and -18i give me -27i. Okay, now I told you I'd make room. I'm gonna make room. Bada boom. All right, so let's move to this next one. 10 minus 7i. That's essentially, because I can feel myself losing time here. In case you didn't know, Zoom has like a limit on how long this can go, which is why I'm talking about a time limit. But that's essentially what my parents did. They did some old camera tricks, some like snapping stuff that got us to believe in Santa for a little too long. All right, 10 minus 7i. Why am I doing it like this? Sorry, 10 minus 7i. The original problem, 10 minus 7i times 10 plus 7i. Forgot that you guys aren't looking at it right here. Okay, so I'm setting up my box method. That's what helps me stay organized. If you distribute, good for you. -70i, positive 70i. Those are going to cancel out. And -7 and +7, that makes a -49. I and I make I squared. Remember, I squared is like saying -1, negative, negative makes positive. So this is all just a fancy way. These two cancel out because we got -70, +70. Get rid of them. 100 plus 49 is 149. All the i's are gone. Our answer is just 149. Imagine. All right. All the solutions of this equation. All right. If we take square root of x squared, we are imagining that our answer would be 4i. It would also be -4i. So imagine this, but with Christmas presents. Okay. On an old VHS. Oh, they got us. How dare they? All right, if we have cube root x to the right, use the graph to estimate the solution of cube root of x is -4.5. So basically, think y is your -4.5. Okay, so go to -4.5 as your y and see what the x is. It looks, did this earlier with a student, and they said, I don't know, I think it's about 92-ish. I don't know, approximately 92, right? Which was a really good guess just by eyeballing it. And I was like, well, let's actually check. Let's do the opposite of this. Let's actually solve this. Let's say, well, let's actually figure out what the answer would be. What is -4.5 to the power of 3? And we did that, and we got x equals 91.25, which means, that was a pretty dark negative. Sorry. It was a pretty good guess looking and saying, oh, about 92, right? So again, you're looking at the cube root there. Cubes can be negatives, unlike squares, which they're positive. Complex number represented by each figure. So imaginary numbers are like your y-axis in this case. So a would be 2 plus 4i. B would be -2 plus 4i. C would be -2 minus 4i. D would be 2 minus 4i. So referring to the diagram, what is the result when we add B? So -2 plus 4i. So if we add that with point C, which is -2 minus 4i, add these, -2 and -2 make -4. 4 and -4 gives me nothing. I just end up at -4, which means I would be right here. That's them added. Inks blending together there. Mobby. All right, onward. Let's even on. So when you see me and it's a little confused, some of the review questions are a little different than last year. So as I flip through them, the slides might not match the numbers exactly. For this, we got D, B, C, and A. Although I'm not a big fan because I think C could actually be argued for this one as well. So if you get a question like that on the test, raise your hand. Let's chat. Yeah, so you can get positive and negative for that negative square root, which is what we been talking about. Cool. But what's important here, square root of 49, unless we ask for a negative for the square root, we're looking for the positive. So if it asks for a negative out there, that's where we would say that D is for sure there. B, again, I could say B and C, B or C there. The solutions, I can see why we're talking about solutions, right? And yeah. All right, let's move on. All right. So we need for discriminant b squared minus 4ac. So remember a, b, c. So b squared here, negative 4 squared minus 4a. C, and you add those together and you end up getting 32. Ooh, nice. It's letter B. All right, again, A, B, C. Let's do a different color. So not everything's blending together. B squared, so we've got 3 squared minus 4, 3, and 2. 2 and 3, 6 times negative 4. 3 squared, 9. We end up doing 9 minus 24. Get negative 15. See? Positive discriminant, look, we'd be looking for a parabola that crosses. Should have said that before. This tells me I'm going to have a parabola with 2 solutions. Red tells me I'm going to have a parabola with imaginary solutions. And then process of elimination, I know what's going to happen here, but let's just prove it. Negative 14 squared minus 4 is 149. Subtract those and you get, yeah, 0. And when that happens, BCA, we would have a parabola with 1 solution. Which we get at here. Oh, man, sneezing. If the discriminant is positive, the quadratic has 2 real solutions. If the discriminant has 0, we have 1 real solution. Discriminant is negative, we have no real solutions, but 2 imaginary. Keep that in mind. What we do to complete the square here? Remember, we got to divide the middle. So divide by 2, which would be 3. 3 squared is 9. So we would add 9 to the end there. Negative 12 divided by 2 is negative 6. Negative 6 squared is 36. So we would add 36 here. 7 divided by 2, 3.5. 3.5 squared. Check my key from earlier on that one. 3.5 squared. Ends up being 49 over 4. I'll just leave it as 49 over 4 for now. But in your calculator, it was probably a good idea to have that handy. All right, 49 divided by 2, 24.5 divided by 2, 12.25. All right. This is what happens when I don't Bring my calculator. All right, speaking of which, let's complete the square to actually find some solutions here. All right, first things first, let's get 8 on both sides here. Remember, we need C away from B. X squared plus 8x blank equals -8. We're going to divide by 2. Divide by 2, we get 4. 4 squared, 16. So we add 16 to both sides. And now we have x squared plus 8x plus 16 equals 8. Okay, now the whole reason we got this is so that we can factor it. So we can write x plus 4 squared, not factor it, but like write it in factored form, equals 8. The whole reason I want to square it is so I can get rid of it with a square root. And now I have my answer being x plus 4 equals, let's simplify this, by the way, which would be root 4 times root 2. So 2 root 2's. So x plus 4 equals a positive 2 root 2. It also, x plus 4 equals a negative 2 root 2. So I write them both because I want to think, okay, I find one solution. The middle of my parabola is going to be -4. Take 4 away from both sides. And now my answer here, I have the middle of my parabola being -4. And one of my answers, one of my solutions, I should say, will be 2 root 2's to the right of that middle of the parabola. And the other one will be to the left. So that's why I'll add my subtraction sign there. So this is really saying 2 answers. This is saying I have the middle of my parabola at -4. One of these answers is going to be 2 root 2 to the right of it. One of them will be 2 root 2 to the left. 2 root 2 is just like a number. Okay. You add and subtract. All right. Christmas magic. Boom. Little delay there. Sometimes you gotta wait for the magic, you know? All right. Let's get 3x to the other side. Hello, honey. Plus 2x equals 9. And I should have left a gap there because I need to split this in half. And now I have x squared. Just really screwing up. Divide by 2 is 1. 1 squared is also 1. That's what I'm going to add to both sides. I'm adding 1. So I have x squared plus 2x plus 1. This is the thing I forgot to do last time I did this problem. Add 1 to the other side to have 10. Okay, cool. So now we can write this in factored form. X plus 1 squared equals 10. Take the square root. And now we have x plus 1 equals root 10. I went to an extended explanation this time because hopefully you guys understood something of what I was doing on the last one, but I'm going to take 1 away from both sides. Now I have x equals, because I got rid of that, I have -1 I should have said root 10 is both a positive and negative version of that. Right, so I have -1, middle of my parabola, plus and minus root 10. And that's two answers. That's like saying x equals -1 plus root 10 and x equals -1 minus root 10. I'm just writing it as one there. So you're saying one to the right and the left. All right, let's complete the square again. Let me get rid of all this stuff first. I'm going to rewrite it here in the middle if you don't mind. X squared minus 4x. I'm not going to screw up and I'm going to leave myself the gap here. I take 5 away from both sides. So I have -5 on the right-hand side. Let's go ahead and split -4 into 2 to get -2. Square it, which gives me 4. Add 4 to both sides. So I have x squared minus 4x plus 4 equals, ooh, almost did it again there, Peter. Don't forget to add 4 there. Equals -1. So x minus 2 squared equals -1. Got a square root of a negative. Alert, alert, square root of a negative. We have a floating parabola. So x minus 2 is going to be equal to positive I, positive and negative I. Okay, so add 2 to both sides. And your answer should be x equals 2 plus and minus I. So you would have a parabola here that's floating above y-intercept, the middle of it be at 2, and these imaginary solutions are both, one of them is I to the right, one of them is I to the left. Hopefully that makes some sort of sense. Quadratic formula. Woo, woo, holla back. Quadratic formula. Leave a comment below if you remember doing this in Algebra 1. Most people say no. We work so hard with you on it. All right. I highly recommend find the discriminant first. So you got 1, -8, 13, ABC. I even write D, thinking about that discriminant, because that discriminant tells me so much. I want to do B squared minus 4AC first. I want to do -8 squared minus 4 times 1 times 13. $64. Brain fart there. 26. 52. Good Lord. All right. Minus 52, which gives me 12. So I have a positive discriminant. Okay. Actually, sorry, everybody. I see the positive discriminant. I know I have 2 real solutions. I like to take the square root of that right away so I can just move that around with me. All right. So I do, instead of writing the discriminant is 12, I would simplify it there, root 4. Root 3 times root 4, which is 2 root 3. Okay, so my discriminant, I like to just write 2 root 3 there. And then the reason I like having this separate, I like having the opposite of B over 2a. I like to think of what that is. That's the middle of my parabola. So the opposite of b, negative, negative, it's already negative 8. So the opposite of b, the middle of my parabola is going to be 8 divided by 2. What's a? A is 1. Okay. Plus and minus. So negative b plus and minus square b squared minus 4ac. I just did all that. I don't want to keep writing that over and over. I just did that. Now I have 2 root 3, which I just found. So middle of my parabola is going to be 8 over 2. That's 4, right? And then over here, this is also over 2a, right? So I have 2 root 3s. Well, I can get rid of those right there. I have 8 divided by 2. Well, 8 divided by 2 is 4, right? So I end up saying, hey, x equals 8 divided by 2. That's 4 plus and minus root 3 over 1. That's just root 3. The middle of my parabola is 4, and the middle of my parabola is 4. One of my answers is plus root 3 to the right. One of them is minus root 3 to the left of that. Okay, I can't do A, B, C, and D if these are all spread out. Okay, I need to get everything to one side. I'm going to get everything to the left-hand side here. I need to add 4x, add 4x. Need to add 44 so that I can get rid of this side and it be 0. I need to add 44 here as well. So now I have x squared plus 14x plus 44 equals 0. And now I can actually set up my quadratic formula. A is 1. That's nice. B is 14. C, 44. Need to do a little work to figure out what my discriminant is. B squared minus 4. A, C. All right. So after 14 squared, 96, and 216. So you end up, not 216, 88. Bring your calculator, folks. 44 times 2 is 88. 88 times 2. 1. Okay. And we get 20. Oh my gosh. All right, so my discriminant is real. I'm going to have two real solutions. The square root of 20 is like saying root 4 times root 5. So I have 2 root 5s as my discriminant. Again, I know that's not proper. I would say that 20 is the discriminant, but I just like to take the square root and have it there. Okay, opposite of B. Opposite of 14 over 2 times 1. I just leave it like this so that in case I can get rid of the 2, which I did last time, that was nice. Plus and minus 2 root 5 over, again, 2a. That's nice. These 2's cancel out. The middle of this parabola is negative 14 divided by 2, which ends up being negative 7, plus and minus root 5. So your answer is x is, you can write it as two separate answers here, negative 7 plus root 5 -7 minus √5. If you can factor a complete square, I recommend it. But if you can't, or if you're just like, you can always use quadratic formula. It's going to take you a while, but all right. Speaking of going faster, all these numbers are even, so I'm going to make them smaller. I'm just going to divide everything by 2. Could you do this with 4, 12, and 58? Absolutely. But the smaller the numbers, the easier the math. Okay, so I'm just dividing this whole thing by 2, which will give me 2x squared plus 6x plus 29. Okay, that makes things just a tad easier. A is 2, B is 6, C is 29. If you did this with 4, 12, and 58, check it. They're the same. It's going to be the same. Discriminant. All right, so b squared, 6 squared minus 4 a c. We get -196. So that tells me that my solutions are going to be imaginary. The square root of -196, -196. My discriminant is going to be positive. Um, 196 is 14, 13, 16. Okay, is square root of 196 is 14. Therefore, square root of -196 is 14i. So my discriminant, 14i. So opposite of b. So -6 divided by 2. Again, I'm just leaving it in long form because I can maybe get rid of some things later. That would be very nice. 2a is 2 times 2. -6 plus and minus 14i over 2 times 2, which I know is 4, right? But there's all these 2's everywhere, right? 14 divided by 2 is 7. -6 divided by 4, right? You're not really going to write that. You're not going to write the decimal usually. You could, I guess you could say 3, -3 over 2 plus and minus 14 divided by 4. You would just leave it as 7i over 2. So again, middle of your parabola is 1.5, -3 over 2, -1/2, 1 and 1/2, plus and minus 7i over 2, like 3.5i. Okay, so your answer would be x equals -3 over 2 plus and minus 7i over 2. All right, hopefully this is helpful. I didn't ramble too much, but the thing you've all been waiting for, the way that the Cunninghams got me and my brothers to take a recording of this of Santa into school when we were in 5th and 6th grade. That's too late. And try to convince our friends that it was real. They set up a camera, hid it in the couch, and then Santa walked in. It was like with a bag and everything. My dad all dressed up with the beard and everything, and then looks, sees the camera, and is like, all right, well, Santa's not going to let himself get recorded. So and the president appeared. And then and another one was there, except he wasn't, right? Like he was hidden and all these gifts were coming. And so we took this recording into school, showed our friends, we're like, see, told you, see why all you guys are wrong. Many years later, it's called like, weren't embarrassed at the time, but then when you realize it years later, you get this embarrassment. Anyway, Merry Christmas, Happy Hanukkah, and everything else that everybody else celebrates. You're gonna do great on your test. Bye.